Hi everyone, my name is Allison Rose and this presentation is for Math 676 for Minnesota State University Moorhead, and this presentation is about defining and adding polynomials. The objectives that I'll discuss in this presentation include students will understand the vocabulary associated with defining polynomials, and students will add polynomials. So first, let's start off with some definitions. A polynomial is basically either one term or a sum of multiple terms that contain variables with whole number exponents. So the exponents need to be integers. So that may include 0. Now, when we are talking about polynomials, a polynomial can have one term or it could have many terms. And when a polynomial has 1, 2, or 3 terms, we have special names for those polynomials. If a polynomial only has one term when it's simplified, then we call it a monomial. These are examples of monomials because they have exactly one term. So this is a monomial, this is a monomial, and this is a monomial. Notice that if there is no exponent, then exponent visible, then that is implied that that's an exponent of 1. And if there's no variable listed, that's an exponent of 0. It would be an x to the 0 power there. And also notice here we can have positive, negative coefficients. We can have radicals, so your coefficients don't need to be rational. They can be real numbers, all real numbers. And so when we're talking about a binomial, bi means 2, so we've got 2 terms for binomials. And then a trinomial, tri means 3, so a trinomial would have 3 terms. And of course, all 3 of these names fall under polynomials. And if you have anything more than 3 terms, we just simply call it a polynomial. Poly meaning many. Now, when we talk about the degree of a monomial and or a polynomial, we are looking at the leading term and the exponent on that leading term. So we're looking at the one term with the largest exponent. So, and we're going to be talking about the degree, so the exponent. So I've given some examples here. When we talk about the degree of 0, the degree is not defined, first of all. For any constant, the degree is 0 because there is an x to the 0 here. You can think about it that way. And if the leading term is just an x, then this is x to the first, so therefore the degree would be 1. And you can see here I'm just talking about the exponent on the leading term here. We have multiple terms. And so in this polynomial, I go to that leading term, the term with the highest exponent, and I just list its exponent as the degree of the polynomial. Even if the polynomial's terms are not in order in standard form would mean that they are in order from highest exponent to least exponent. Even if they're not in order, you still list the highest exponent. So this one would be a degree 4. So now we need to be able to interpret some additional definitions. And to do that, we're going to first talk about subscripts. Subscripts are used when we are talking about polynomials and we don't know exactly how many terms we will have. So we can basically, it's a way of naming a coefficient and a term. So this would mean this is the nth coefficient on x to the nth. So the n is the exponent. You can think about it as the nth term in this polynomial, not including this last constant term. Okay, so subscripts are just used to distinguish one constant and one coefficient from another when we have many of them and we don't know exactly how many of them we will have. So a polynomial, we define it like this, where we have a coefficient on each of our terms. This a sub n is a coefficient on the x to the n term, the a sub n minus 1. That just means that it's the very next term in the sequence all the way down to a sub 0. This is our constant term. So you can see the exponents are decreasing by 1. The n's are integers. These are positive, non-zero integers here, or non-negative integers, I mean. These are non-negative integers for n. So we will have an x to the 0 power right here for the constant term. Now, the leading coefficient, there's one thing about this. The leading coefficient on this x to the n, this cannot be 0. If this is 0, then this entire term goes away, right? So in your polynomial, you can't say it's a fifth degree if the coefficient in front of that x to the fifth is 0, because then that term doesn't exist. So you're talking about the leading coefficient on the leading term here, as long as this is non-zero. Now, polynomials, when we put them in something called standard form is simply when we put the terms in order from highest exponent to smallest exponent. And remember, if there's a constant in there, then this would mean that that's an x to the 0 power. So if I were to take a look at this polynomial right here, I would have an x to the first and an x to the 0. So this x to the first term needs to be listed first. What you need to make sure of is that any sign that belongs to these numbers stays with the proper number. So the negative actually belongs to the number to the right of it. It belongs to the x. The way I like to tell my students is that if you look to the left of the number, that's its sign. It has to stick with the number. So I'm going to be writing a negative x first, and then I look to the left of the 4. And that's the sign that I'm going to write with the 4. Since there's no sign listed here, it's going to be positive. So I will write negative x plus 4 for my standard form. Again, notice our coefficients can be radicals. They don't have to be rationals. We are simply looking at the exponents, though, to put this into standard form. So the 5x squared is positive when I look to the left, therefore I write positive 5x squared. You don't need to have the plus there. The next term that I will write is the x to the first term, which is this root 3 times x. I look to the left, since there's no sign, it is a positive root 3x. And then I look to the left of the 4, that is a negative symbol, so I have to write minus 4. And this is the last example here. The terms are very jumbled up. I look for that highest exponent, and that would be this 2x to the 7th. So that has to be written first. I look to the left. This is a negative 2x to the 7th. So I write that negative 2x to the 7th over here. The next term that I would have to write is the x to the 5th. Look to the left, this is a negative 4x to the 5th, so I write down minus 4x to the 5th. And again, 7x cubed, this is a positive 7x cubed, so I will write plus 7x cubed here. And the last term is a negative x squared, so I have to write a minus x squared at the end. Notice these are in descending order from highest to lowest exponents when I am done. Now we're simply going to talk about adding polynomials. I have written out one example here, and so this would be the original problem. Take this polynomial and add this polynomial to it. So on the right hand side here, you'll see my explanation of the steps in the process of simplifying. And over here, this is the algebra associated with the explanation. So the first thing I would do here is I have actually color-coded the terms in each of the polynomial for like terms. You can see this 3x cubed is green, and so I went to the other polynomial and I found all of the x cubed terms, which there's only one. So I made both of these green. These are like terms. I did the same thing with the x terms here, so I have a positive 2x and a negative 2x over here I highlighted. And notice I highlighted the sign to the left because that is the sign that belongs with the number. So I'm going to be combining these later on, so I needed to highlight the sign to go with it. Notice there is only a negative 5x squared in the polynomial on the right hand side, and there is not an x squared term in the polynomial on the left. So that's just one term I have nothing to combine it with, and that is okay. I also have a constant here. Notice there's a radical in there, and that is okay as well. Not all constants or coefficients have to be rational. They can be just real numbers as well. So, and actually, in the text, they can be complex numbers. It's just that that's not until later on in the text. So that's why I've only included radicals in this. So now what I'm going to do is I'm going to use the associative property, and I'm going to simply reorder these terms so that my like terms are next to each other. So I've rewritten it so that my green x cubed terms are right next to each other. Notice I brought the signs with them. And I also have my negative, I've also put them in descending order with the exponents. So my cubes are first, my square is second, my x to the first is third, and then my term without my constant terms are last. So now what I have to do is I have to add these like terms or combine these like terms. So what I've done is I have written with parentheses around the coefficients here. I've basically factored out this x cubed, but you can just think about it as I have added the coefficients. So 3 plus 4 of those x cubed gives me 7 of those x cubed. And since I had nothing to combine this 5x squared with, it's just going to stay in my problem, and that's okay. Notice here on the x term, I have 2 minus 2 times x, and this turns out to be 0x, and 0 times anything is 0. So this is no longer impacting my expression, so I'm going to eliminate that term altogether since it simplifies to make 0. And now notice also I have some like terms here with the radicals. I've got negative 3 root 2 minus 7 root 2. That adds up to make negative 10 root 2. So adding a negative is also the same as subtraction. You'll notice I did write in here plus negative. And that is just simply because we are adding the coefficients, so adding a negative is equivalent to subtraction. So that is why I did that. And then when I write my final answer, I end up with this 7x cubed minus 5x squared minus 10 root 2. I wrote my answer without any parentheses and without the 0x term in there. I hope you have found this helpful for just understanding polynomials a little bit better and adding polynomials.